Hello ladies and gentlemen, welcome to this part 5 of the SDL programming tutorial. Right away there's a couple things I want to mention. I've been looking over at how I'm doing these tutorials, and thank you. If you have left me any feedback and I haven't read it yet, I thank you anyway. I do very much appreciate your feedback on how I'm doing things. I would like to definitely hear more and see more viewers and stuff like that. So I know you noticed that probably that I've been kind of dragging stuff out. I'm not. The idea is to explain to you everything clearly, because what I hate about, and this may be my personal opinion, but what I hate about tutorials sometimes is when you open up a tutorial and they just assume you know what they're doing. You know, like they will start writing a function, right? And in the middle of this function, you'll see some weird convoluted call to like SDL blitz surface, right? And you're like, what in the world was that? And then all of a sudden, he just, a person just mentions, oh, this is to help us do this. And, you get no explanation whatsoever as to why that particular thing is doing what it's doing. Why do you have to write that? Do we just have to memorize it? I mean, that's why it gets kind of complicated. What I'm trying to do here is I'm trying to explain to you every line of code that I write, so you know that this is here for a reason, that this is here for a reason, that there's no line in here that you should have a question about, and if you do, please let me know. I mean, you can even say, hey, I don't understand why you have like line 10, and I'll be like, oh, okay, well, that's a constructor for this C app state class, and the reason we have it is just to follow a convention because we have a destructor here, which is a virtual destructor, and I'll go into that and I'll explain it all over again. So if you want me to, please let me know. That's one thing. Second thing, once again, me trying to hurry through these videos, and I mean, not hurry, obviously I'm not trying to hurry, as you can see, but I try to put a lot of information into these, and so sometimes I forget the obvious. Like, for example, this class that we did 2 videos ago, I've bluntly forgot to include the H file for that same class. So I'm going to include it now. CApp state H. As you can see, this red mark here means it didn't compile. I'm gonna get into habit now of always compiling files when I stop, right before I stop the video, so that you can see that it compiles. Like right now, see, process terminated, 0 errors, 0 warning, 0, and that's what I'm going for on all these files. Now you can't compile the H files, you can only compile the CPP files. So you go to CPP file of the C event, you hit compile current file, and then you are able to see that result. Well, actually here you see no result because it says nothing to be done, which just basically means that it's been compiled already. It's been compiled before in the previous session. All right, so anyway, I'm gonna get into a habit of always compiling all the files. Right now we have 2 files. We have the C event, we have the C app state, and we're about to have CSurface.cpp, which is going to define this class right here. Now, as I've mentioned in the previous video, these are kind of the videos go right after another. So first we do the C event.h, then we do the C event CPP. Actually, I can go ahead and close these right now because we're not working with them. This is CAppState.h and CAppState.cpp, and I can close these also. And now all we got is the CSurface.h, right? So I'm going to go ahead and start the CSurface.cpp. Okay. All right, so CSurface.cpp. Right? And again, we added to both debug and release targets, no problem, blah, blah, blah. Here's our file. Now, one thing, let's not forget that again, when you're doing a CPP file for the H file, you need to include the H file. That's just that's kind of obvious there, because these files go together, because that file uses the functions from this file, uses functions from that file, so they need to be connected. Otherwise, the compiler will have no idea what you're talking about when you say unload. So let me go ahead and split the screen like I did a video ago. Not a video ago, a couple videos ago. So I'm going to split my screen like this. I'm going to make this area smaller just so you can see better. And I realize that, this font is probably way too small for you guys. The thing is, I'm trying to fit a lot of information on my screen. If it's too small, please go ahead and watch this in full screen. That's probably when you're going to get the best kind of view of it. I'm going to try to increase, like what I just did is I increased my font there a little bit, hoping to get you a little bit of a better view. But, you know, and I'm going to make this a little smaller, like so. So mostly, this is our writing area, and that right there is going to be the class that we're referring to for these functions. We're just going to go ahead and define these functions. So the first function we're going to define is going to be this onload. So what we do is we just simply go ahead and copy, if you want to be lazy, just go ahead and copy this, Control C, Control V. I'm going to copy this header over exactly as it is, okay? And I'll just get rid of the semicolon and open up the function body. All right. So this is going to be a. Oh, by the way, always add a qualifier. You should know this from basic C++. But when you're defining functions that are part of the class, you should always specify what you're talking about. You should always specify that you're trying to define a function onload out of CSurface class. See, if I just did this, that would be legal C++. But what it would think is that I'm defining a global function called onload that has nothing to do with this file. See, you have to be explicit. You have to say, this is a CSurface onload. That's what it is. You have to put this qualifier before the name. So, once again, it's a function that accepts a file name in a basic C++ string. It's going to take that file name and it's going to do some magic in here, which we're about to write, and it's going to return a pointer to the surface, which is going to be a surface that contains that image, assuming that file name actually is a valid file name that points to an image. All right. Now, couple things here right away. Let me just mention something. SDL by itself is only capable of working with BMP files, which is bitmap files. Okay. However, there is an extension library that I hope you have installed. If you haven't, look up and try to install it. And if you think I should do a tutorial on how to do all this, how to install it, I can. But basically, there's an extra library that I've installed. It is called SDL image. Okay, right here, you can see in my linker options, and I'm sorry, this is probably tiny for you, but you can see right here that I'm also linking SDL image. Now, this library right here has additional functions that allow me to load stuff like JPEGs and PNGs and GIFs and I'm not sure what else. I think TIFFs. I'm not sure. Anyways, this is a library that allows us to load stuff other than bitmap, and it does so seamlessly. See, what you would do is there's a function in SDL called SDL load bitmap, right? And I can use that, or instead of it, I can use image load. So I can use that. All right. So either one of these will do fine. I will use image load because I can, but if you don't have an extension installed and all you have is a way to work with bitmaps, go ahead and change this to SDL load bitmap. Okay. They both work exactly the same. So this function in SDL, it almost does exactly what we want to do. So then your question would be, okay, so why in the world do we need to redefine onload and wrap it around when we actually have a function that almost does exactly that? Not almost, exactly does exactly that. I mean, it's a function called SDL, either load bitmap or image load, which will take a file name. I mean, who cares if it's a C string instead of C++ string? You can still give it the file name just like that, image.bitmap, right? And it'll return a surface. So why not? Why do we need to do all that mess? Well, let me explain to you what we need to do. Let's go ahead and try it as if we were just oblivious to that fact. And we're going to go ahead and load it up using that function, and then we're going to return the surface. Okay, so first what I'm going to do is I'm going to create here a surface, and I will call it temp surface. Okay? Now, notice again, this star. This star always goes along with this asterisk, This asterisk always goes along with SDL surface. Why? Because as I've explained previously, any surface is located on the heap memory, which means that we're never actually working with surfaces directly, we're working with pointers to surface. So here I created this temp surface. Now, I could, of course, simply do temp surface equals image load, okay? And I could do like, okay, so we have that file name up there. Now this file name is a C++ string. So and this function actually accepts a C string. So all we got to do for that is we got to say file name and then do this little dot and call the C built-in function called cstring, cstar. That's what is going to basically take that file name, which is a C++ string, and generate a C string from it. And then that's going to be fed into the image load function, which is going to return a pointer to SDL surface. So you would think that you can just do return temp surface. Okay? And if you run this, you will actually find out that it works, you know, it works almost like it works like it should. It does what it does the job. So then your question is, what is the point of all of this? We don't need this. We could have just used image load everywhere we need to load an image. However, there is a distinct problem you have to be aware of. You see, images, they come in different formats. And what I mean by that is I don't mean JPEG or bitmap or any of that stuff. What I mean by that is they come in, like, the information inside the image file is stored in pixels, right? Some of them are compressed pixels, like if it's JPEG or if it's you know, ping or something like that, it's going to be compressed using a specified algorithm. And if it's a bitmap, all you do it's just a list of dots, basically, a list of colors. Now, those colors are different. The amount of information stored for each color is different for every file. Like, for example, you could have two different bitmaps, but one of them is a 24 color bitmap, 24 bit color bitmap, and the other one is like only an 8-bit color bitmap. Okay, they both are going to look exact. The files are both going to have an extension BMP, but they're going to have a distinctly different type of color information stored in each pixel. Well, the problem is that right now there is no. Right now everything seems fine, right? We load the surface, great, but then you realize that you're not just going to hold on to it. You're going to have to. You're going to use the onDraw function, which we're going to make later. This onDraw function to draw this surface onto another surface, and that's where you're going to run into problems, because you see that other surface probably will have usually. Okay, here's what usually happens. Usually, at least in the beginning stages, you're going to draw on the display surface. You see, I didn't explain to you what that means right now, but one of the surfaces is going to be designated as the main window surface or a main display surface, and you're going to have to define the color depth for that. So, you know, and the format for that. Now, let's say that you're loading this image from the hard drive, right? What's to say that that image is the exact same format that your display is? Well, it may be, it may not be. But if it's not, what SDL does for you is it automatically converts it to the format of the display. It does so seamlessly. You don't have to worry about it. So it actually will work. This, in practice, if you just run this, it'll work perfect, it seems like. However, it's going to waste lots of precious processor cycles, because converting that is a very expensive operation. Because you don't realize this, but the computer actually has to go pixel by pixel, converting the image to its current. If a format is at all different from the display format, it has to convert it to a display format before blending onto a display, or before pasting onto a display. Or if you just draw this surface on another surface, still it has to match the destination format. So it has to go pixel by pixel and convert all of that mess. So we don't want it to automatically convert. Normally, every image that you bring into the program from a file, you want to go ahead and convert right away, once and for all. Convert it to the display format, right? Whatever our display format may be. There is an easy way to convert a surface to a display format, and it's called SDL display format. So instead of returning this temp surface right away, okay, we're not going to return it right away. What we're going to do is we're going to get rid of that, okay? We're going to get rid of that right there, that return statement. And first of all, there's a couple things. Let's check to make sure we didn't fail, okay, at this point, because at this point we can fail. What if this file doesn't exist? I mean, what if the file name was passed in and it was a bogus file name? So the file name didn't exist, which means this function failed, which means temp surface is still equals to null, right? So, you know, it's because the image load would give it null if the file name was bogus, or if the file was unable to be found. So right now would be a good time to check if temp surface is equal to null, okay? Now, I prefer this full notation. Some people prefer this kind of notation, if bang temp surface. I feel like this is more illustrative when you just write null. You know, if temp surface is null, so if this points to no surface because the surface didn't get created right there, what I want to do is just return null, which is going to mean that the null is being returned and this produces null. All right, so you know, it just kind of takes that null and passes it forward, and doesn't go anywhere past this point. However, if temp surface is not equal to null, which means we have successfully loaded the file, right now would be a good time to create another surface, which is going to be our final surface. Okay, final surface, and that's the surface we're going to actually return. Then we take this final surface, knowing that temp surface already contains a good surface there. We take this final surface and we call this SDL display format. SDL display format. And what SDL display format does is it simply takes another surface as an argument, like temp surface, right? And it converts it to what is the display format. Now, right now we have no display format, but we're gonna set it eventually. Whenever we create a main game window or main game screen, we are going to define what our display format is, and as such, this function SDL display format will convert this surface to a new surface based on the display format, and then output it here to final surface. Now, however, a word of warning: now that you've done that, this temp surface didn't go anywhere. You see, this temp surface didn't get converted to final surface. What display format did is read the information in temp surface and create a brand new surface and assign it to the pointer final surface. Which means, what all that means is now you have the responsibility of freeing this surface from memory. Okay, so now you have to free surface temp surface, right? And that is what's going to free that surface so that it doesn't waste memory. So once again, we created a blank pointer to the surface. We loaded the surface from a file here. We checked if we successfully loaded it from a file, and if not, we just return null instead and get out of this function. Then we create a brand new pointer to the surface called final surface. We use SDL display format to get the information from this temp surface and convert it to the current display format. And then finally we free the temp surface because we don't need it anymore. And we return final surface. Remember that these are all pointers. So since this is saying SDL surface pointer on return, you can just return final surface. You don't have to use this. That's fine just the way it is. Because final surface is everything that is a surface is a pointer. Temp surface is a pointer to surface. Final surface is a pointer to surface. So you don't have to worry about any of that indirection stuff. Okay, so there you have it. Now you have a function called onLoad. Okay, wow, I'm already at the 18-minute mark. This is gonna have to be a long one, guys. I'm sorry, but it just it has to be if I'm gonna be that detailed. You let me know if this is a little too detailed for you. Okay. So the next function in line, that's gonna be this bool on draw thing, and that's going to draw one surface onto another surface. Okay. Now this function is going to require a little more work. What I just did is I just went Control-C, Control-V, and I pasted this function over into the file, so we don't have to, retype all of that. I'm going to get rid of this semicolon and open the body of the function. Now this is the version of onDraw that simply draws one surface onto another and doesn't clip. Doesn't clip anything. It just takes this source surface, takes this destination surface, and then pastes the source onto the destination with its corner being at these coordinates on the destination surface. Okay, so here's what we're going to do here. First off, now for those of you, you may already know that there is a function to actually do that in SDL, and that function is called SDL blit surface. Okay, now for those of you who don't, blit, that's an abbreviation which I honestly don't remember. I think it's something like layer image transfer, but I'm not quite sure. I apologize for that. Blit is a technical term used by game designers and graphic designers, which basically means to take one image and paste it onto another. So blit surface, that's what this is. That's not I, that's L. BLIT blitz surface. All right. So this function, what it does is it does exactly what we want, except for it has these really weird parameters that it accepts. You see, blitz surface has it has 4 parameters that you have to pass to it. The first parameter is obvious, and that's our source surface. The second parameter, and I'm going to skip that for now, the third parameter is destination surface. All right, and then fourth parameter I'll also skip. So these two, so basically it's like it's got source here, it's got something here, and it's got destination, and it's got something here. But, well, these somethings are going to have to be, the way that this function works is it requires a pointer to SDL rect to be passed. SDL rect is simply a type in SDL that is that defines a rectangle. That's all it is. It's that simple. It's not. There's nothing horrible about it. It's just it's like a structure. It's not even a class. It's a struct. It's a class with 4 public variables in it. Okay, and those public variables are x, y, h, and w, where x, y are the coordinates of the top left corner, and h and w are height and width. Right, that's what SDL rect is. So you can literally create an SDL rect like this. SDL rect 1, right? And then you can do rect1 dot x equals some number, rect2 dot x dot y equals the other number, and so on and so forth. And you can fill up this rect1 information, right? Then this function requires the rectangle to be passed to indicate where to clip and where to draw. So basically it works like this. The first parameter is the source. The second parameter is the source rectangle, which is the rectangle that we can use to clip, or we can also pass null as a second parameter. That will indicate we don't want any clipping done. And then here, this is the pointer to a destination surface, which is just dest in our case. And then this is the destination rectangle, which actually the height and the width of that are not even being used. Just this is how it's going to accept the x and the y. All right. So instead of just having an x and a y, it's got this rectangle that you have to create and then fill up. That's annoying. That's really annoying. If you had to do this every time you want to draw something, oh, now I got to create this source rectangle. I got to create this destination rectangle. Well, we're going to do this in this function, but that's the only place we're going to do it, because after that, you're going to be able to just call on draw, say which surface, say to which surface, and say where. And that's going to be drawn. This is much more intuitive than this blitz surface deal. Right? So, but obviously before we blitz surface, there's a couple things to take care of. If you notice, the function is returning bool. That means that we want to be able to check for failure. Well, here it's really easy to check for failure. There's only one way that this function can fail. This function can fail if either a source doesn't exist or a destination doesn't exist. So that's an easy check. If source is equal to null or destination is equal to null. So if any of those are true, we return false and forget about it. That's it. And we return false, and the bleeding just didn't happen. Drawing just didn't happen. Now we're on this line 19, and that means we got past this part. We don't need to return false anymore, which means source and dest both exist. So now, as I've said before, we have to create this SDL rectangle, and we'll call it destination rectangle, dest R. Now dest R is going to get assigned, the x of that rectangle is going to get assigned destination x, which is from right here, this parameter, okay? And then destination y is going to be assigned, destination r dot y is going to be assigned destination y. Same exact way. There's no height, there's no width, okay? So the function doesn't actually use those values. So now we can just do the blit, SDL blitz surface, and our source is SRC, which is from this right here. The next parameter is just going to be a straight up null, okay, because we're not doing any clipping. The third parameter is going to be a destination, okay. I'm sorry for this prompt, this tooltip that keeps popping up, blocking what I'm typing, but source, null, destination, and finally the pointer to this destination rectangle. Now, the parameter that it requires is not the destination rectangle itself by value, but a pointer to one. But since here we just went ahead and created this variable, we have to pass it with the address of thing, this ampersand. So dest R. All right. So that's it. we blit that surface, source, null, dest, and dest r. That's what the idea is. So that's how this function works. Source rectangle, destination rectangle, and we have null for a destination. That's actually why this function accepts pointers instead of like the by value rectangles. The reason why it does that is so that you have an opportunity to write null if you want to just skip a parameter. Like here, I don't want to clip, so I just write null. See, if it accepted an SDL rectangle as a parameter, I would have to give it something, even if it's blank. I'd have to give it some sort of rectangle. Here I don't have to. So that's it. The blit is complete, and we can safely return true, indicating that we are successful in our venture, that we were able to draw this function out. Okay, we are now at 25 minutes of recording time. I really don't want to split this class into 2 recordings. I guess I should maybe try and hack it. Try to do it, even though that's going to be a long video for you guys. Please, complaints are very, very welcome, as long as they're polite, I don't do this for money, obviously. Don't do it for any kind of gain. I'm doing it for you. So if you feel like it's too long, too short, too detailed, less detailed than you want, let me know all those things, or ask for clarification on any of that. So now the next function that we're going to do, that's going to be also the onDraw, which is just going to be the other onDraw, right? The overloaded onDraw. That's the one where we, let's see, yeah, that's the one where we clip. We draw, but we also clip. Oh, and let's get rid of that static thing, and bring it up just like that. Okay, and well, we can bring it up in here. Basically, the idea is I'm trying to use as much space as I can, but not go over the 80 character margin, which is kind of the good style to use. Get rid of the semicolon and start the definition. Now, the first part of the definition is identical, literally. Like, you can take this right here, this entire thing. This, first of all, if we check if source is null and destination is null the same way, then we create a destination rectangle the same way. So all of that can just basically go whoop, copy, right? No problem. We just copied that whole thing. Now, the only thing we don't have is we also need to define another rectangle, which is going to be our source rectangle. Source rectangle, right? And in this rectangle, we're going to have the information of where we're going to clip. And that's easy as pie. All we got to do is take this source rectangle and assign to it all the values that we have in our parameters here. You see? All the source x, source y, width, and length. So for the source r.x, we can assign source x. For the source r.y, we will assign source y. For source r.width, we will assign, actually we called it width, right? Over there in the parameters. And source r.height, we can do height. And now we have 2 rectangles. So now, guess what? SDL blit surface, right? And in SDL blit surface, now we have all 4 parameters. So source, I apologize once again for these tool tips. Dest source and source rectangle, and then destination, and then destination rectangle. There you go. So that's what our final blit surface function is going to look like. Okay, remember these ampersands, they are very important. They indicate that we're using the address of the source rectangle and not the source rectangle itself, right? Whoa. Sorry, I did not mean for you guys to see that. I was just holding my shift button for too long, I guess. So there you go, and return true. Now we have 2 of these functions defined. Now the final one which is set transparent color. Now this one, I'm going to come very close to kind of, remember that thing that I said that I hate that people do when they write tutorials? Just kind of tell you, oh, look, this is how it's done, memorize it, and just get over it. All right? Well, I'm going to show you something very close to that, but I am going to be as detailed, as close as I can to explaining what that means. Okay? So just bear with me. All right? So this last function is called set transparent color. I'm going to copy it from the bool part. Oh, and by the way, this thing right here, I forgot to add the CSurface qualifier, so I need to go ahead and do that now. CSurface qualifier on draw, CSurface qualifier on draw, and CSurface qualifier for set transparent color. That's because, as I said in the beginning, we need to qualify all these functions to let us know which classes they came from. So this is the final function in the class, and what it's going to do, as we've discussed earlier, it's going to set the transparent color for this particular surface, and we have our 4 parameters, which is the target surface, the red, the green, and the blue color on the transparent to indicate which color we want to set as transparent. Now, as you probably guessed, there is a function in SDL to do exactly that. However, the call to this function is, well, let's just say slightly more convoluted than I like. Let me show you what I mean. First off, let's deal with this Boolean thing. Once again, we want to make sure that we account for failure. And failure here means that target surface doesn't exist. So that would be an easy check. If target is equal to null, return false. That was an easy one. Alright, so now we have this R, the G, and the B. Now, the R, the G, and the B, they obviously stand for red, the green, and the blue. If you don't know this already, this is a quick discourse for those of you who have no idea how colors are represented on a computer at all. And I'm sorry for those of you who have to wait through this just a little bit, 5 minutes. Okay, so the color information on a computer is usually what we do is there is the red, the green, and the blue channel. Okay, and the amount of these channels is how we come up with any color. All right, let me show you what I mean. Let me if you haven't done this before, I'm gonna open Paint on my computer. Right, I'm gonna open Paint. It's a basic Windows painting program for those of you who really are up in the clouds. Okay, and I'm gonna show you like this Edit Colors box right here. See, you see this box? You must have seen this box at least once or twice. You know, even if it's not in Paint, there's similar boxes to this all over the place. Now look at these numbers right here in this corner. You see this, the red, the green, and the blue. You see, as I move this thing around my screen, you see how my, well, actually, it's set to, I'm sorry, that's what I meant to do. Okay, my slider wasn't up. Now take a look at, as I'm moving this cursor around the screen. Don't worry about the hue, saturation, and luminance. That's different representations of the same color. Look, what I want you to look at, this red, green, and the blue. You see how they have numbers that are constantly changing as I'm moving around, but notice that they never go under 0 or over 255. 255 is the highest amount of color that can have. And look, I can actually edit these manually. Like I can, for example, set it all red, no green, and no blue. Okay, and now I got this bright crimson red or whatever. I'm not sure. You know what? My colors are really bad. I'm not sure if that's called crimson. I'm not sure. The point is that's red. It's bright red. And same thing I can do. I can set 0 red and like full green. And then I'm going to get this bright, almost kind of lettuce green. I don't know what you call that. The point is that I can control these colors with these numbers. I can say, and if I set them all to 255, which is the maximum they can be, I get white color, or the absence of color. And if I set them all to 0, I'm gonna get black. Yeah, you guessed it. So that's what the colors, how they work. Okay, the colors are red, green, and blue usually. Now, once you get into advanced colors in game making, there's also such thing as an alpha channel, which is kind of like a blending. It makes those kind of soft blends from color to color. But we're not going to even worry about that right now. The red, green, and the blue is all I want you to kind of comprehend at this point. So the red, the green, and the blue can represent almost any color that the eye can see. If in those, that's, I mean, right here, like for example, look at this color right now. Like, right, you see this color, this blue right here, this blue in this square. Do you see it? Okay. Now let's say I'm gonna add like 1 digit of blue to it. I'm gonna, like right now my blue is set at 209. I'm gonna switch it to 210. Do you really see much of a difference than what it was? Let me try that again. 09, 10. That's an identical blue. You see, your eye can't even tell the difference. My eye can't tell the difference. So this is like several million, I think, colors. The 24-bit color. That's what we're dealing with here. 24-bit color. 24 bits because there's 1 byte per color and there's 3 bytes. 3 bytes is 24 bits. Because there's 8 bits per byte in most machines. So that's what how the color is usually represented. You can represent any color you want with these 3 numbers. So let's get out of Paint after this little demonstration and get back to what we were doing. So that's what these red, the green, and the blue mean. So using this R, G, and B values, you can represent any color that the eye can see, almost. Okay, and don't let the painters hear that because they will tear you a new one. They will let you know that no, the computer can never come close. Whatever. This is what we have to work with. This is the best we got. So the computer can represent basically any color distinguishable by the eye with these R, the G, and the B. So what we do with this, and like I said, we check to see if our target is null, and the target is if the target is null, we return false, right? Now, what we're gonna do is we're gonna use an SDL function called setColorKey. Okay, so just like that, setColorKey. Now, as I've said before, this call to this function is a little more convoluted than I generally like. In fact, it's very weird because you have to call one more function inside this function to get it to work. Now, the first parameter to this function is obvious, and that's the target surface that you want to do it to. Fine. The second parameter is a flag parameter. Okay, that's where you want to set up. That's where you set all kinds of. That's where you are able to set these things called flags. This is where we come close to the part where I said that I'll just have you memorize some stuff, because honestly, these flags might as well have been avoided. I'm not sure what the people were thinking when they were designing SDL, but they require you to put these flags in there, and I will explain to you what they mean, don't worry. But they could have been made the default as far as I'm concerned. But the first flag is source color key. Actually, you have to write it like this: SDL source color key, just like that. All right, which basically that's us reiterating what we want done. Okay, that's what we want to do. We want to set source color key, but for some reason you have to indicate that as a flag in here also. And the second flag that is usually recommended here is this RLE acceleration. Okay, and honestly, I'll tell you right now, I can go into a great detail about what RLE acceleration is, but trust me, you won't need it. Basically, the idea is this: RLE acceleration makes it faster. That's all you need to know. RLE acceleration makes it faster at this specific this operation faster. So SRC color key is what we're trying to do, and RLE acceleration basically means do it the fastest way you can. Okay, and there are some times when this fails, which even though I've never seen this happen, but according to SDL manuals, sometimes RLE acceleration fails on some machines, and so when it does, go without it, and it'll still do the same thing, right? So you have these flags. The first parameter is the surface, pointer to the surface. The second parameter is these flags, which are largely useless according to me, but they need to be put there because the creators of SDL said so. And the third parameter, okay, now this is where it gets weird. The third parameter is the color. Well, that's funny because we got the R, the G, and the B, but the parameter is just one parameter. How are we supposed to indicate the color with the R, G, and the B? Do we add them up together and put the added number? And how do we calculate the final number? Well, this is a bit tricky because, as I said, the surfaces can have different formats, so the color can actually be encoded in them differently. So it's not always like whatever you think the R, the G, and the B is not necessarily what they are, because our R, G, and the B, the way I've explained it is there's 1 byte, like between 0 and 255 for each of the colors. But what if you're using a file where there's only like from 0 to 100 for each of the colors? So then where would you be? So how are you going to add those up? Anyway, there is an easy way out of this, but it requires that I go to the next line like this, and because I'm going to write a lot right here for the third parameter. The third parameter is going to be generated by a function called SDL map RGB. Okay? And what this function does, so it's a function call inside a function call. This is a function that's going to actually generate that third parameter for us. This function is known as the universal color translator. Okay? You see how convoluted this is getting? That's why we're creating this set transparent color. That's going to be nice and easy for us, because now we have to do the set map RGB, right? And inside the map RGB, there are 4 parameters. Get this. There are 4 parameters inside the map RGB. The last 3 being the R, the G, and the B, respectively, right? And the first one is the target surface format. But what the hell is a target surface format? Okay, now we got that problem. All right, so but don't worry, it's all gonna be very clear in a second. But you see how they're trying to confuse you. It seems like the map RGB function accepts the format of the pixels and then the R, the G, and the B in the format which you're used to, which is the 24-bit format. So where are we going to get this mysterious format number? And what does it mean? Well, you know what? You don't need to know what it means, but you do need to know where to get it. And where to get it is, you simply get it out of the target surface. So the target surface within itself actually has some members. And one of those members is format. Look at that. So you could just put the format right there, and that's going to extract the format right out of the surface we're trying to do it to. So based on that format, and then here I'm going to pass the R, the G, and the B. And I apologize once again for this computer, but you'll see it in a second. Okay, so here we are. All right, now, just so you know, I don't want this to look too convoluted for you, I'm going to recite it back from the inside out. So this is the function that we're calling to do this job. Okay, it's an SDL function. It has 3 parameters. One is the target surface, which is fine. The other one is the flags, which are largely useless, but we do have to put them in. The third is the color. Okay, and that right there generates our third parameter for us, which is another function called to map RGB, which takes 4 parameters. One is a format, and the other 3 are R, the G, and the B, respectively. So these things we get out of right there. That R is that R, this G is this G, this B is this B, and the target format we get out of target. Okay, we use this indirection arrow because that's a pointer to a surface. So to get one of its members, you have to use this, it's called dereferencing or indirection operator to get to the format. So finally, once this is done now we've accomplished what we wanted. But you see how much we had to type to get that simple thing done. All I want to do is set the R, G, and B transparent color for a target, and I had to go through like double indirection to get this done. I had to set color key, and then inside that I had to map the RGB color. That's why we do it once, so we don't have to do it again. That's the idea. We're lazy. Programmers is a ultimate lazy profession. We make programs so that computers do our work for us. That's the idea. We don't have to lift a finger. So that's it. After this is done, we simply return true to indicate our function is completed successfully. And this time, before I finish the video, and this is going on 43 minutes now, I apologize to everybody. I know you waited long enough, but you know what? You could pause. I should have said this earlier. You could pause and come back to it, okay? So what you can do, I'm going to go ahead and compile this file now to see if it compiles, okay? So there's no... Oh, and you know what? Let me bring this log part up right here. Okay, okay. Alright. Oh, and look, I've got an error. Alright, first of all, it's telling me the image load was not declared because I've misspelled it, because it's like that with a capital L. Alright, so that's one problem. The second problem, it tells me the height was not actually declared in this scope, so let's see what's going on. Oh, well, that was kind of weird. Width and height, but in my case, it's width and length. So, yeah, I shouldn't have done that. It's actually width and height, so I don't know why I named it length. Let me go ahead and change that to height here. And see, this is why it's useful to have that file open and this file open at the same time. Okay, and you could really see the differences. So you can change this stuff to height, and now you have it defined. So let's try that again. Build, compile current file, and once again I'm getting a... Oh, Well, of course. Okay, if you're using the image load like I did right there, if you're doing image load, you do have to include that separately from SDL. Now, you realize that SDL is already included right here at the top of CSurface. Actually, let me bring that in. Okay, you see that? How we included SDL right here in the Surface H file? Well, the image load is actually part of the expansion of SDL, which is located inside the SDL image. So you have to include it like this, SDL image, right? And that is what's going to get that to compile. So let's try that again, compile current file. And let me bring the log up again so you can see it. And look, this is what we're looking for. Process terminated with 0 errors, 0 warnings. By the way, guys, yeah, I know I haven't mentioned this yet, and this is the last thing I'm going to say, I promise. As you can see right here, this is my compiler line. As you can see, I've turned on all my warnings. This is what this W all means. And also I have my errors set on pedantic level. Okay, what this means is basically I want clean compiles always. I'm sorry, I'm a stickler for clean compiles because warnings pile up. Trust me, you do not ever want to reduce your warning level. If your compiler is warning you about something, take that warning seriously, please. By all means, take that warning seriously. This is what you should want to see in your compile log: 0 errors, 0 warnings, and hopefully 0 minutes. But that's well, that's a stretch. Some computers, but 0 errors, 0 warnings on pedantic level with all warnings enabled. This is what you want to see, because sometimes you see even those little things that are like, oh, you can't compare unsigned to assigned, and people just leave that alone, and the warning just stays there, and they just turn off their warning level. Well, you turn off your warning level, you're liable to miss a serious warning that is there for a reason. So you might as well just get into a habit of getting every program to compile cleanly like this. Alright, so now we have officially declared 3 classes. We got CSurface class, we got CEvent class, and we got our CAppState class. And this has been part 5, I believe. Yeah, this has been video number 5, and it's ended up being a very long one. And the next time, in part 6, we are going to get back to our CAppState, and we're going to look at how to declare more application states that are going to inherit from CAppState. There you go. You've been great. Thank you very much. Enjoy your evening, and I'll see you back for the next set. Have a good one. Bye-bye.